Now that you've seen how nanography works, let us show you what the printed output looks like. We are now going to compare the offset printed dots with which you are also familiar, with inkjet printed dots, with nanographically printed dots, and in this example, all on ordinary, plain, uncoated paper stock. Offset printed dots have poorly defined edges and non-uniform density. Inkjet printed dots are even more rare, with poor optical density. And this is nanography. Note the extraordinary edge sharpness, high image density, and uniformity. Such a startling effect deserves a more in-depth explanation. You see, as the ink penetrates the paper, much of the pigment ends up below the surface, reducing optical density and uniformity. And just as ink gets absorbed into the paper fibers, it also wicks along the paper fibers, making the edges red. With Landa nanographic printing, a dry ink film is applied to the paper, so there's no penetration and the edges are super sharp. Since these ultra-thin film images are literally laminated to the paper, they conform to its surface roughness right down to the topography of individual paper fibers. This accounts for nanography's extraordinary ability to match the gloss of the paper, whether coated or uncoated. Unlike conventional inks, in which the pigment particles are many hundreds of nanometers in size, Landa nano ink pigments are merely a few tens of nanometers. These nanopigments are not only super efficient absorbers of light, but they also don't scatter light. These properties give Landa nanographic printing the broadest CMYK color gamut of any printing process. So what have we seen so far? We've seen that the thickness of the ink film has a profound effect on the properties of the printed page. And the thinner, the better. There's another benefit to thin images. Thin images require less material to produce than thick images, and so they cost less. In this comparison of various printing processes, you can see the reason that Landa nanographic printing is the lowest cost digital printing process of all. Pardon me. Now, I am asked, why did we develop nanography based on water? Why is nano ink an aqueous printing process? Why not, for example, solvent-based or UV-based? And the answer is very simple. Even if our customers could afford them, our planet cannot. And that is the reason that nano ink is based on pure, clean water.